Good morning, students. This is next group, that is 18th group elements, and this is the last group in P block elements. The elements present in 18th group elements are helium, neon, argon, krypton, xenon, and radon. These are the symbols of the respective elements, and these are the atomic numbers of respective elements, and these are the electronic configurations of respective elements. Next, what is the point? What is the next point? If you see the general outer electronic configuration, general outer, that means this one 2s to 2p6, 3s to 3p6, 4s to 4p, all are similar. So that what we can say, its general electronic configuration is ns to np6. So that is the general electronic configuration of 17th group elements. Next, these are also called inert gases because they are chemically inert. That means chemically inert means their outermost orbit is completely filled. That means they are unable to get electrons and they are unable to lose electrons, so that they are unable to involve in chemical reactions. So that is why they are called inert gases. That is the reason behind that one. Next, these are also called noble gases because some elements only form compounds under drastic conditions. This is also a very important question. One more question. Why 18th group elements are called noble gases? What is the reason? Only few elements, not all elements, forms compounds under drastic conditions. Drastic conditions under high pressure or high temperature or low pressure or low temperature, not at standard conditions. That is why these are called noble gases. Next, these are also called aerogens because all gases present in air. Why these are called aerogens? Because they are present in air. Next, these are also called rare gases because they constitute a very low amount. That means its percentage is 1% in atmosphere. That means very less abundant in atmosphere. That is why these are also called rare gases. Next, here one more point is there. This group is also called zero group elements because its outer electronic configuration is completely filled, so that its valency is 0. That is why we should not say its valency 8. When outer electronic configuration is completely filled, then their valency is considered as 0. So that these are also called zero group elements. Next one, general properties. Before that, one point is there. In this group, radon is the radioactive element, and which is obtained by disintegration of radium. Here, radium is second group element, 2a group element in S block elements. When this radium undergoes decomposition, then we get radon along with helium. This is considered as here alpha particle. So radon is a radioactive element in this group. Next, all are monoatomic gases. All are monoatomic gases. Next, general properties. Atomic size. We know that from top to bottom atomic size increases due to increasing number of shells, thereby xenon having more atomic size and helium having less atomic size. So its order is helium less than, neon less than, argon less than, krypton less than, xenon. Next, IP. When atomic size increases, IP decreases. Both are having inverse relation. So that helium having more IP and xenon having less IP. So that the order is helium greater than neon, which is greater than argon, which is greater than krypton, and which is greater than xenon. Among all these elements, helium has highest IP. Here, one more important point is there. That is, Not only in this group, among all elements in the periodic table, helium having more IP. That is very very important question. Not only in this group, among periodic table, helium having more IP. Next, EA. EA means what? Electron affinity. This is also called electron gain enthalpy. When any electron is added to an atom, then some certain amount of energy will be liberated. That energy is considered as electron affinity. That is the definition actually. So most of the elements having negative values, EA values, because when we add electron, that energy will be released. But in some cases, energy will be absorbed. In that some cases, this group is there because all are having completely filled configuration in their outermost orbital. When we add electrons, some repulsions will occur. So to avoid those repulsions, we have to apply some energy externally. Then that energy is absorbed, and that energy will utilize to remove the repulsions between addition of electrons and existence of electrons, so that the EA of 18th group elements having positive values. So that is the reason behind positive values of 18th, positive EA values of 18th group elements. Next, boiling point, melting point. Melting and boiling point of these elements are very low because of presence of weak van der Waals forces. Because all are gases, between gaseous molecules van der Waals forces are present, but those van der Waals forces are very weak. But their melting point, boiling point increases from top to bottom due to size increases. Helium has lowest boiling point among all elements because size is very less. It boils at 4.4 Kelvin. That means helium can be converted into liquid at 4.4 Kelvin temperature. Sorry, not it boils at 4. That means helium can be converted into vapor at 4.4 Kelvin temperature and liquefies at 2.2 Kelvin temperature. That means at a 2.2 Kelvin temperature, that helium can be converted into liquid. At this temperature, helium can convert into vapor. At this temperature, helium can convert into liquid. So this is the order of melting points and boiling points. So among all elements, helium having less melting point and boiling point, and xenon having more melting point and boiling point. Next note. The first inert gas compound is XePtF6. This is called xenon hexafluoroplatinate. That is the name of this compound, xenon hexafluoroplatinate. That is the first inert gas compound. That means xenon forms first inert gas, first compound from inert gases. This was discovered by Berthollet. Next, compounds of xenon. That means among I told you already, only few elements forms compounds. Among few elements, xenon is the one of the element. That means mostly xenon forms compounds. Now that is why we have to discuss about compounds of xenon. Xenon difluoride, that is XeF2. How to prepare xenon difluoride? When xenon directly combines with fluorine in the presence of 673 Kelvin temperature and 1 bar pressure, then we get xenon difluoride. In brackets 2:1 is mentioned. That means what? Experimental, not theoretical. Experimentally, 2 moles of xenon and 1 mole of fluorine. Then we get xenon fluoride. That is the meaning of this one. Next, one more point. When xenon difluoride undergoes hydrolysis, then xenon, HF and O2 will be formed. Here one important point is there, that is, see in this XeF2 xenon having plus 2 oxidation state. Here xenon having elemental state, that means 0. From plus 2 to 0 oxidation state decreases, so that in this reaction xenon undergoes reduction. When oxidation state increases, oxidation. When oxidation state decreases, reduction. Next, XeF, that means how to prepare. When xenon reacts with 2 moles of fluorine, this time in the presence of 873 Kelvin temperature and 7 bar pressure, then we get xenon tetrafluoride. Experimentally 1:5 ratio. That means 1 mole of xenon and 5 moles of fluorine. Experimentally, not theoretically. Next point. When xenon tetrafluoride undergoes hydrolysis, then we get xenon, XeO3, HF and O2. Here one more point is there, important point, that is what in this XeF4 xenon having plus 4 oxygen state. Here xenon 0, here xenon plus 6, here plus 4, here 0, here plus 6. That means from here to here oxygen state decreases, but from here to here oxygen state increases. That means xenon undergoes both oxidation and reduction. That is why in this reaction xenon undergoes disproportionation. Here xenon undergoes reduction, here xenon undergoes disproportionation. Next, XeF6. How to prepare XeF6? When this time xenon reacts with 3 moles of fluorine in the presence of 573 Kelvin temperature and 60 to 70 bar pressure. 60 to 70 bar pressure. Then we get xenon hexafluoride, and experimentally 1:20 ratio. That means 1 mole of xenon and 20 moles of fluorine experimentally. When XeF6 undergoes hydrolysis, then we get XeO3 and HF. XeF6, in XeF6 xenon having plus 6, in XeO3 also xenon having plus 6. That means here oxygen state neither increases nor decreases. That means xenon does not undergo both oxidation and reduction. In this case, in XeF2 case, xenon undergoes reduction. In XeF4 case, xenon undergoes disproportionation. That means both oxidation and reduction. But in this case, xenon neither undergoes reduction nor undergo oxidation. Next, one more point regarding XeF6. When XeF6 undergoes partial hydrolysis, that means partially means stepwise hydrolysis, then following reaction takes place. That is, when xenon F6 reacts with 1 more water, then we get xenon oxy tetrafluoride, XeOF, and again this undergoes hydrolysis, then we get xenon dioxide difluoride. Again this one undergoes hydrolysis, then we get xenon trioxide, that is XeO3. That means when XeF6 reacts with 3 moles of water, 1, 2, 3, then we get finally XeO3. So this is the overall reaction, this is the individual reactions. Next, here you have to remember the reactions as 15th group, 16th group and 17th group elements. Next, here one more topic is there, that is we have to discuss these compounds. That means we have to discuss its hybridization, lone pairs, oxidation state, shapes. These are very, very important. First compound XeF2, not Fu2, XeF2, xenon difluoride. If you apply the formula P equal to G plus M minus C by 2, where G is group of the central atom. In all these cases, group is what? 8. Just think like that. Group is 8. 8 plus, because these are having 8 electrons in their valence shell. That is why you have to put 8. 8 plus 2 minus 0 by 2. That means 10 by 2. That means 5. That means P value is 5. If P value is 5, its hybridization is sp3d. Next, how many number of lone pairs? Lone pairs equal to P minus number of surrounding atoms. P over how much? 5. 5 minus number of surrounding atoms 2. 5 minus 2, how much? 3. Next, what is this oxygen state? Plus 2. If sp3 dihybridization having 3 lone pairs, then its shape is linear. So it is the shape of this compound. You have to remember these 4 columns, not 4 columns, 5 columns. These are very, very important. Definitely you will face one more question regarding this one CBSE level. Next compound XeF4, not FeF4, XeF4. What is the same formula? If you apply that formula, then you will get hybridization, lone pairs, then automatically we get shape. XeF4. What is the formula? P equal to G plus M minus C by 2. Where G is 8 plus 4, 12 minus 0, because charge is 0. 12 minus 0 by 2, that means 12 by 2, 6 means sp3d2. How many lone pairs? 6 minus 4, 2. So sp3d2 having 2 lone pairs, it's automatically its shape is square planar. So like that you can calculate hybridization of every compound and lone pairs of every compound. Automatically we will get a shape of the compounds. Otherwise we will discuss those. If you have any doubts, we will discuss in live class later. Next topic, uses of helium. Helium, it is used as diluent. Diluent means it helps other substance to dissolve in blood. This is used by deep sea divers. Deep sea divers means deep sea divers. They are the divers which are in sea, under the sea. Those are called deep sea divers. They use helium along with the oxygen. Then automatically that helium helps oxygen to dissolve in blood. That is called diluent. That is the one of the main important use of helium. Next, second use, it is a non-inflammable gas. That is why it is used in filling balloons for meteorological studies. Next one, it is used in cryogenic studies. Cryogenic studies means the reactions which takes place at low temperatures, that is called cryogenic studies. The helium is used to provide low temperatures. Those are the uses of helium. Next, uses of neon. It is used in fluorescent bulbs for advertising purposes. Generally we see so many times advertising bulbs, they are having different colors. So neon is used in those bulbs. Next, used in botanical gardens. In botanical gardens also so many bulbs are there. In those bulbs neon gas will be used. Next, uses of argon. It is used in extracting metals by providing inert atmosphere. Extracting metals means refining of metals from their impurities. That is called extraction of metals. So argon is used to extract the metals by providing inert atmosphere. Next, it is used in electrical bulbs. Now we are in electrical bulbs, in household bulbs. That bulbs contain argon. Next, similarly, krypton and xenon are also used in electrical bulbs. Next, radon is used in the cancer treatment. Next, this is last topic, that is when xenon fluoride reacts with fluoride ion donors, then xenon fluoroanions are formed. When they react with fluoride ion acceptors, then xenon fluorocations will be formed. Xenon fluorides means XeF2, XeF4, XeF6. These are called xenon fluorides. Next, PFI, SBFI. These are 15th group fluorides. 15th group, phosphorus 15th group element. SB, antimony. This is also 15th group elements. These fluorides are called fluoride ion acceptors. That means when these compounds react with xenon fluorides, they gain fluoride ions from other substance. They gain. That means these substances gain fluoride ions from these compounds. MF, the metal fluoride, nothing but 1A group fluoride. This is act as fluoride ion donor. That means when this compound reacts with any substance, then this compound loses its fluoride ion. That is why these are called fluoride ion donors. So these two 50A group fluorides are called fluoride ion acceptors. 1A group fluoride is called fluoride ion donor. When these xenon fluorides reacts with the 15th group fluorides, then these fluorides gains fluorine from these compounds. Then automatically XCF2 become XEF. It loses F minus, that is why it gets plus charge. Automatically PF5 becomes PF6 minus. Similarly XCF also, because this is also SPF5 also act as fluoride ion acceptor, so that XCF4 loses on fluorine, automatically XCF4 becomes XCF3 plus, and this part becomes SBF6 minus. But in last case, metal fluoride, that acts as what? Fluoride ion donor. That means it donates fluorine to this one, so that XCF6 becomes XCF7 minus because it is gaining. Then this part become M plus. So these are very, very important reactions. These are important in competitive level also. So we may face some questions regarding this one. The question model is here. When XCF2 reacts with PF5, what is the product formed? That is one model. One more model. When xenon fluorides acts as fluoride ion donors. When xenon fluoride acts as fluoride ion donors. What is the answer? That means when xenon fluoride acts as fluoride ion donors, when they react with the fluoride ion acceptors, then only they act as fluoride ion donors. Suppose in the first two cases, xenon fluorides acts as fluoride ion donors because these are fluoride ion acceptors. Automatically these will act as fluoride ion donors. These are very, very important reactions. You have to practice them. So this is all about 18th group elements, and this is the smallest chapter in class 12 chemistry.